Hi there, this is Dr. Embuddy. We are at Project 11, last one. So the idea of this project is to look at how a network is analyzed, like for example, a Facebook network. And so how do we represent friends, you and your friends and the connections that you have in a computer. And this type of thing is very useful for studying communities of people. Something like this was used, for example, to capture Saddam Hussein. They built a network of all his friends and acquaintances and so on, and by connections to connections, they were actually able to figure out who was important to him, and then that information was used to actually find him. And this has been done for other other criminal networks. And here we're looking at the strength of somebody. So, for example, people want to know, or companies would like to know who the influencers are. And what kind of a network do they have, and how strong are the connections, and how wide are those connections, and so on. And so what we're doing in this project is we're looking at some of the techniques that underlie that. So let's take a look. To start with, what you want to do is you want to think of you. Okay, so here's the ego, and that's me. I am the center of this network that we're looking at, and you have some friends. You've got Mary, and you've got Bob, and so on. Right, and they have connections. So Mary is a friend of yours. Bob is a friend of yours. Mary and Bob are friends also. But let's call this Carol. Bob and Carol, so Carol is a friend of mine, and Bob and Carol are friends. But notice that Mary and Carol are not friends, because there is no line or edge, as we call it, connecting those two. How do I represent this in a computer? Well, we're going to use this as a dictionary, and it's called the social net. And it will be my social net, and I'll actually have a number. I'll call it 12. That's me. I'm 12. And I will have a set of friends that will be Mary, Bob, Carol, and the other ones that I have, the other nodes that I have here. Okay, that's my set of friends. Now, since Mary and Bob are also friends, so if I look at the social network for Mary, and she'll have some number in this, Mary's set will include Bob and me, and I guess we better give this one a name. We'll call this Jean. So Bob, me, and Jean are in Mary's set. And if I look at Bob, so if I look at Bob in here, Bob will have a set that will have me. Notice, it's because the set ordering doesn't matter. Mary, Jean, and I guess we better give this person a name, Frank, and Frank, and Carol. I get that right? I got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so Bob's got 5 friends. Now, that's how our friends are represented, and this whole thing is centering around me, the ego, right? The ego, the I, the id, and each of these actually, instead of having names, because the data that we use is real, it's anonymized, and so each person will actually have a number, just like I gave myself the number 12 here. And there are other types of, well, first of all, let's add somebody. Suppose we have another person here called Ted. Now, how do I add Ted? Well, I have to, and let's pick a color here. And so one thing I have to do is I have to add Ted to my list. So Ted has to go into my set here. And we have to create one for Ted. So and in Ted's set will be me. Right? And so we have to put Ted into my set. I'll call this me here, and then we have to put me into Ted's set. Okay. Now, at the same time, suppose Ted and Carol are connected. Well, how do I do that? Well, that means that I have to add Ted to Carol's connection. We don't have Carol in there. Bad idea. Let's add Ted to somebody that we already have in here. Let's add Ted to Bob. All right. So we add Ted to Bob. And so that means now we have to have Bob in here in Ted's list. Oops, Bob. And now we also have to add Ted into Bob's list. All right. So notice that we did 2 different things here. One, the first thing we did was we added a node. Now, it turns out that these things are actually not called friends, but they're called alters. So we add an alter to my ego net, to me, and we added this connection. We added a connection between friends, which are called alters. So this was, these are methods in my ego net. There's 1, and there's 2. And let's actually now take a look at how those are done. But notice, let me review what we did. When we added Ted here, we had to put Ted into the ego. Right? We added Ted in there. And because we did that, we had to add me into TEDs. Right? And of course, this being a dictionary, if TED didn't exist, I have to create the entry with me in there, right? Standard dictionary type stuff. Then I added a connection between Bob and Ted, so I had to add Ted to Bob's, and I had to add Bob to Ted's. So that was adding a connection, and the other one was adding an alter to the eagle. So let's take a look at how that looks in code. So I have an ego net here, and we give you the init, and here's adding an alter node. That's adding a friend to me, and it had some steps. What did we do here? Maybe I'll leave that pass there. You know, what did we do? Well, we had to add, in the case we added Ted. We added my alter. That was Ted in this case. To my social net. And what's my social net? Well, my social net is up here. Ego. And so when I said that I added it to my social net, I'm adding it to that. Right? And so I have a social net, it's a set, and I'll add Ted to it, which is my alter. There he is. That's the parameter. Add Ted to my social network. And then, so because I add Ted, I then have to say, okay, add me to Ted. And so that would just be the reverse of it, you know, just like we had before. Instead of ego there, that will be Ted. Instead of alter there, that will be ego, except be a little careful. It's actually not ego, it's self.ego. So I'm saying take my social network, those are my friends, and you know, we're doing this to me, and we're going to add Ted. And then when we want to reverse it, that will be Ted, that is the alter, and that will be me. And now you have to be a little careful to make sure that you check that Ted exists. Just any typical dictionary things in the social network. And finally, don't forget, we keep a count of my friends. That's my friend count. So remember, oops. Got to remember to increment your alter count. Okay, so that's how we added a node. Now, how did we add a connection? Well, we had two connections. We had Ted and Bob, right? And so, you know, how do we do this? Well, we have to add alter1 to alter2's network, and we have to add the reverse. And again, as with any dictionary, we have to remember to check that it exists. And if not, we have to make sure, like we saw, we didn't have Ted in there, so we had to put it in there. And again, now many of these other things are single line type of operations. Okay, so let's take a look at so you have to fill in the rest of these. Let me talk a little bit more about about our network of friends. So, for example, we have again, this is me here, and there are certain characteristics of friends. So it may be that this friend and this friend are friends of mine from MSU. It may be that this friend is from high school, and this one is also from high school. It may be that that this particular person is male. Maybe I'll even make another circle here. Right, that one's male, and and maybe this one is also male. And these things are known as circles. So I have my MSU circle, I have my high school circle, I got my male circle, and so these features help us define circles. And now how am I going to represent this kind of thing in a computer? Because I got these, I got my MSU friends, I got my high school friends, I got my male friends, I got my female friends. How am I going to do this? Well, let's go down here, and here is how I might do that. So this is alter once. That might be Mary, Bob, Carol, and Fred, whatever they are. And they got a bunch of things, like, so maybe this is the MSU, these are the high school friends, here's my males, and here's my people with black hair, whatever. All right, so we have these different features, and then a one is sort of like a check. Okay, so Carol is my one MSU friend. And in high school, oh yeah, these guys are all from high school. And which ones are male? Oh, these two are males. Which ones have black hair? These ones have black hair. So we have each person has a bunch of features. They either have that feature or not. We could have used true and false. We use 0 and 1 just because that's how we, it's a little easier for us to represent them in the files. And so here is the feature files for the ego 1, 2, 3, 4, and here's all the different people, and here are their features. So that's this file is representing this type of situation. and those are for all the different people. We have a separate file that just has the one for the ego. For me, this is my ones. We have another file that says who your friends are. So, so this right here is this. This, oops, that's a bad color. These are my friends. So 345 is friends with 244 and 765. 765 is friends with 345, of course, and with 244, and so on. And these are, this file is my features. Ego. All right, and you'll notice that there's 1, 2, 3, 4, 5 there. There's 1, 2, 3, 4, 5 here. Those are mine. And then we can have circles. So here is a here's a file of, oops, here's a file of circles with a name. These people have the same concentration, like, you know, maybe the same major. These people are in the same school, you know, and who has the same concentration, but this person, this person, this person, and this person. Okay. And then we extract those out of this file, where you know, this, we use this. You know, so these are the features. So this is feature 6, which is in position 0, and it's got this weird format. It's got a birthday and this, you know, it's been anonymized. Well, they've all been anonymized, and some of them have IDs. So basically, when you read this file, you ignore these and so on. Okay. And I guess the reality is you ignore that word, and so you build out of, this is the position 0, that like being position 0, and this would be the birthday one. You know, there's 4 of these. So I made up names like MSU and so on, and this is actually the file that that labels those. You know, the birthday, the concentration, the degree, the school, and so on. And that helps us keep track of those. So that's those are the files that we're dealing with. And so if we go to the proj11, you know, we give you the thing for reading in the files. I decided tonight when I was putting this together that I'm going to give you that. When I'm done with this video, I'm going to add that to the skeleton file, so you'll want to pick that up. And then we give you the main. And what does the main do? Well, first of all, it reads all the files, and it creates this dictionary of features, and then we use that to build the node, the central node, my node. That's my node. I'm the center of all this. And then once I create that node by using the node class, so this is an item of the node class, then I need to add my features, right? And so now my node has my features in there. What school did I go to, right? These are my characteristics. And then I'd add me to the, I now create an econet. Notice, I created a node for me, and then I create an econet. So that's the whole network that I'm creating there, revolving around me. All right, so that now creates the network. And then add my friends. Remember, alters are friends. So I'm going to add my friends to my network, and then we add, which of my friends are connected to each other. So this is where we put in, who friends are, and then we add in the circles. Okay, so here are all the people that went to the same school. Here are all the people that have blonde hair. And that type of thing. And then, so we have all these functions. We gave you that function. And I think I gave you that function. And, where we're adding these features on there. And so let's see, get ego and net. Let's see. Now I gave you, which one did I decide to give you? I decided to give you add them onto the egos. Okay. And let's take a look at let's take a better look at one of these. So here, what is this one doing? This is adding my friends. I'm going to go down here. Right. Here is when I'm adding my friends. So I made my econet, and now I'm adding my friends. And so what does it mean for me to add my friends? And I'm reading this file of features. Actually, that's not adding my friends. Here's where I'm adding my friends. But what I want to do is, so first of all, I'm adding my friends to my network, and then I'm including their friendships. So I want to take a look at adding my friends to my Facebook. Let's take a look at that. And so what do we do in this? Well, we're going to go and add add my friends in here. And so we're going to loop through my file. My alter features file. And just like any other file that we do, is we got to split things, right? And what else do we have to do? And what do we get out of that? Well, we get a node ID, because that's how the file is set up. And we get all the features that are associated with that node. And then, based on that, I can create a friend. Oops. And we'll still use the word alter. I could do a friend. And now I have to build. You've got to figure out what goes in there. I create that node. And then, what do? I now, loop through the features. And then, remember, my alter is a node. Oh, and so how do I add features to a node? Well, let's go and let's get the node file. All right, and if we look through there, there it is. Here's how I add a feature, and what does it have? It takes argument of a position and a feature. So that means that I add a feature, and what does it do? It takes a location. So we'll be grabbing my eye there, and then I need to build a feature. All right. And what does this look like? This line right here? Yeah, it looks exactly like this line. So, I'm taking a node, I'm adding a feature, and you get to use that line that I gave you before. Now, after you've done that, what do you need to do? Well, I then need to, I've got my EgoNet, and I need to add an alter to it. There it is right there. Now that I've got this guy, I can add him in there. We don't use self because self is that guy. And I've just built an alter. I added features to him. Now I can put him in here. And then I believe my instructions say I have to return my EgoNet. And that's how I go about that. That's the algorithm there for adding my friends, that is the alters, to my network. There's a few other things in here. So one of your choices is to figure out the EI index, which, well, if this is a simple formula based on E and I, and so we give an example of how you do that. You just have to follow along with that. How is effective size done? Well, here we have the ego. He's got a bunch of friends, a bunch of alters, and you calculate what's called this redundancy. And how does that work? Well, let's take a look here. It looks threatening, but it's actually pretty simple. Let's start with node A. All right. There are how many friends here altogether? It's 1, 2, 3, 4, 5, 6 friends. And A is connected to 3 of them. So we have 3 over 6. How about B? B is here. All right. B is connected to 2 of them. Notice that's the connection to the friend. So that's 2 over 6. C doesn't have any friend connections, 0 over 6. D has 1 friend connection. E, here's E, has 1 friend connection. F has one friend connection. You add those up, you get 1.33. That value goes in here. And so you take the total number, the 6, that being actually the same as that 6, and you subtract what you calculated here. So now your challenge is, how do you, well, the 6 is actually easy because my ego node keeps count of how many alters I have. That's trivial. How do you find out what each friend is connected to? Well, you do have your social network. All right, and the entry for A is what? It will be the set E, F, and B, and you ought to be able to look at that and come up with the 3, right? And you got to go through all those guys. And one thing that I found handy is, okay, so I'm in my ego net, and look at that, get all the alters. Well, if I have all the alters, then I can loop through them. Boy, that's easy. All right, and then we do something similar with the efficiency. We need the actual size. That's my 6 again, and the effective size. That's this value, 4.67. So you've already calculated that. So this one's real easy. All the work's done for you. Now you've got the 6, and then in that previous figure, which again was just a function, you get to calculate that. So this is an exercise in building our class and then using them. Hopefully that gives you enough to get started on.